Hey BC, let's do some vector valued functions. This is the second of your homework assignments. This is sort of the answer key you're going to have, and this is available on OneNote, so maybe you'll see it there also. So I gave you parts of 3 AP problems, 95, 97, and 2011, I think. Yeah, so let's go. This one I said everything except part D, I think, though. So let's do 95 first. Okay, so two particles move in the xy plane for time t is greater than 0. We have the position given by these two functions, x equals t minus 2 and y equals t minus 2 squared. Okay, so when we give these things, right, this is going to give ourselves a position. You can think about this like parametric equations, just like you did in Math 3, perhaps, right? And so this is saying, like, at time t equals 4, you could say, oh, the x coordinate will be 2 and the y coordinate will be 4. And, you can sort of just move along from there, right? So to find the velocity vector, right, that velocity vector is going to be sort of x prime comma y prime, right, with these brackets there to denote that it's a vector. And so that's just going to be 1 comma, what is this? This would be 2t minus 2 times 1, right? So 2t minus 4, I think. And that's just that. So at t equals 3, this would just be 1 comma 2. Okay. And then, so this is for vector A. Sorry, I completely missed it. There was vector B. Vector B over here, that's going to be, what, 3 over 2 comma 3 over 2. And that's just always that, right? So this is one of my answers. This is the other one of my answers at t equals 3. Right, that other guy's moving with a constant velocity. And you'd see acceleration would be 0 if we were to do that. Okay, so setting up an integral expression that gives the distance traveled by particle A from t equals 0 to t equals 3. Okay, so distance traveled, is that this guy right here? Distance traveled, we know, right, is the integral of speed, right? The integral of that absolute value of the velocity, or the integral of x prime squared plus y prime squared. We see these things here, right? So these are sort of things that we want to memorize. So when we come down here, and I want to find this distance for A, right? This is just going to be the integral from 0 to 3, right? My time t equals 0 to t equals 3 of the square root of x prime squared plus y prime squared, right? That's what we just said that was, dt, right? So this is going to be the integral of from 0 to 3 of the square root of 1 squared plus 2t minus 4 squared dt. Okay? I don't think we actually define that, right? Just set it up. Okay, good. Wouldn't want to, right? This one in particular looks a little bit like arc length, just because of that one, but again, that's more coincidence, right? Because that x prime is just 1. Okay. Determine the exact time in which the particles collide when the particles are at the same point at the same time. Justify your answer. Okay, so all we want to do then is just set these two guys to be equal, right? This t minus 2 has to be equal to 3t over 2 minus 4, and we have to check the y coordinates. Check the y coordinates, right? This is not really calculus at all. Right, so we'd solve this, right? I get t over 2 over here and 2 over here, so I get t equals 4. And then so we're saying the x coordinates are the same at t equals 4. Are the y coordinates also the same at t equals 4? And you can see that they are, right? Y of 4 is going to be 4 minus 2 squared. and y of 4, right, this is just 4. Y of 4 for my other guy is 3 times 4 over 2 minus 2, which is, of course, 4 also. So at t equals 4. Are they guaranteed to collide? Same time, same position? No, right? They're not. Okay, but these ones happen to. So that was 1995, A, B, and C. That should have been relatively straightforward as a warm-up. Let's talk about 1997. This guy. Okay. During the time period t equals 0 to t equals 6, particle moves, and we got some trig fun. That may or may not be fun for you. Okay, so, and I don't know if I said I didn't want you to do B. Oops. Okay, well, maybe you did B, maybe you didn't. They don't really ask us to sketch very much anymore. Okay, so we're not going to do this guy, but let's talk about A. Okay, so find the position of the particle when t equals 2.5. That is literally saying x of 2.5 is 3 cosine 2.5 pi, and y of 2.5 is, 5. 5 sine 2.5 pi. 2.5 pi, that's 5 halves pi, that's pi over 2, right? So this guy's going to be 0. And this guy, sine of pi over 2 is 1, right? So this is 5. Okay, so it's at 0, 5. Not very interesting. Okay, so more interesting, right? Part C. How many times does the particle pass through the point found in part A from 0 to 6? Okay, so we have to think about the period here, right? And the period is normally 2 pi, right? So it's 2 pi over that b there, right? So this period is going to be 2, right? This is a period of 2. I think you can agree that each of these functions is a period of 2. If you think back to your TIC days, right? So this thing is period 2, then it should cross by 3 times, right? From 0 to 6. That should make some sense. Okay, find the velocity for the particle at time at any time t, right? So this is taking derivatives, right? So x prime of t and y prime of t. So x prime of t is going to be what? It's going to be 3 times 2.5 times negative sine. Oops, not 2.5. What am I doing? Pi. Taking the derivative of this silly thing. 3 pi negative sine pi t. Right, because it's a chain rule. And then this guy down here is going to be 5 pi cosine pi t. Okay, so written as a vector, right, we give it a little hat if we wanted to. Right, this is going to be 3 pi, negative 3 pi sine pi t, comma 5 pi cosine pi t. Okay, there we go. And then lastly, write an evaluate an integral expression. Right, remember this was a calc problem. In terms of sine and cosine, it gives the distance traveled from this thing to this thing, right? So that is, again, 1.25 up to 1.75. Those are my bounds. And then I'm going to have that first thing squared plus that second thing squared, right? So negative 3 pi sine pi t squared plus 5 pi cosine pi t squared dt. Okay. And you guys could evaluate that. I did look the answer up here. It says it's 5.392 if you want to check your Desmos work. Okay. Sorry, my kids are yelling downstairs. I don't know if you can hear them. Sorry about that. Let me just... Yeah, I think they're fine. Okay. So let's move on to 2011 maybe. I said this was far down the packet. Looks chronological. Look at Missy M being organized. Okay. So this is a more modern one and more along the lines of what I think you might be asked now. Those old ones are sort of to get our feet wet. Okay, so 2011, at time t, a particle moving in the xy plane, we're not explicitly given, okay, but we are given these derivatives here. Okay, so find the speed of the particle at time t equals 3. Okay, well, speed, right, if you think about this, is Pythagorean theorem, right? How fast am I changing in the x? How fast am I changing in the y? Right, we can do speed is equal to the square root of dx dt squared plus dy dt squared, right? And so in that case, again, this is a calc problem. What are we talking about at t equals 3? So this is going to be square root of 13 squared, that's dx dt at 3, plus sine of 9 squared. And this thing is a little more than 13, I think, right? Because sine of 9 is going to be 13.006 is what I see here. Okay, so, and then for B, and find the acceleration. Acceleration vector, right, that's just going to be taking our derivatives, right? So acceleration is going to be equal to what? 4, that's the derivative of 4t plus 1. And then my other friend is going to be cosine t squared times 2t. And then at t equals 3, right, this is 4 comma cosine of 9 times 6. And that turns out to be, let me look here. I'm cheating here. 5.466 negative. Okay. So, and you know, these, I think this could be a 7 and this could be a 7. Right. We can truncate, we can round, it doesn't matter. Both will get full credit. Okay. So B, find the slope of the tangent line, to the path of the particle at time t equals 3. Well, that's just going to be dy dx, which is dy dt over dx dt, right? And dy dt, we already found these things, right? This is sine 9, and this is 13. Right, that's how fast those things are changing. Right, this is going to be small. It's 0.032 or something. Okay. Find the position of the particle at time t equals 3. Okay. So now we need to use our knowledge of the fundamental theorem, right? And so we sort of have two problems here, right? And we know that the integral from 0 to 3 of dx dt, right? Well, this is going to be equal to the antiderivative of dx dt, which is just x, right? So that would be equal to x of 3 minus x of 0, right? So we could solve for x of 3 this way by saying, okay, x of 3 is going to be equal to x of 0, if we add it to the other side, plus this integral here. And what is dx dt again? It was 4t plus 1. Right, this one we could do by hand. I'm going to, again, cheat and say we get 21, but you guys can do that by hand. Y of 3, we're going to need to use our calculator, but we're going to get the exact same sort of setup, right? No, right, you could just duplicate this setup right here, and you'd be happy, right? So from 0 to 3 of, what is it? Sine t squared dt. Okay, this is a job for Desmos. And y of 0 is negative 4, I think. Right, so it's negative 4 plus this thing, which again we'd use Desmos for, and we get negative 3.226 or something. Right, so the position is 21 comma this thing. Okay, That's not so bad. And then find the total distance traveled, right? Again, that's just plugging. This is a very common question, as we can tell. Maybe not quite as common as, every single vector valued function problem. Maybe it is. But this is, again, going to be the integral of the square root of dx dt squared plus dy dt squared, right? It's the integral of speed. So this is at a specific point. Well, we'll just do it in general. In general, oh no, because we're doing it. Is what 4t plus 1 squared plus sine of t squared dt. Okay, and I think if you plug this in, you're going to get 21.091. 29.091. Okay. So again, I hope this helped clear up some of those concepts, right? It's just like regular calculus, except you sort of have two problems for the price of one with a lot of these guys, and then just sort of memorizing, how to find speed and how to find slope and how to find total distance traveled and all that stuff. But I think you guys should be good. All right. Excited to see you guys soon.